To begin modeling the roof, we first need to start with the inclined wall and the inclined beam, which will support the roof structure itself. To do this, we go to the view named Roof Start, which you can find here in the project browser. In order to see the plan we used in the previous video, we'll need to adjust the view range settings. Click on Edit View Range and leave the first two settings as they are. For bottom and depth, we'll set both with an offset of -1. Click OK, and now the roof plan we were working with in the previous video becomes visible. The first thing we need to do to model the roof is create this inclined wall. It's very important that this wall follows the same specifications as the existing one on the opposite side so that the roof sits uniformly on top of both elements without any issues. To ensure this, we'll draw a guideline showing exactly how far this wall extends. That way, when we model the new wall on the other side of the module, it reaches the same point and matches the same slope. Go to the Architecture tab and select Model Line. We're going to draw a line that follows the same path as the red line visible in the plan, which indicates how far the wall on the opposite side reaches. Select the start point here, draw the line across to the other end, and make sure it's aligned perfectly. Now we have a straight line that follows the same alignment as the red reference line. If we select the existing wall and look at it from the top view, we'll see that the end of that wall lines up exactly with our new guideline. With that guideline in place, we can go back to the roof start view and begin modeling our masonry wall. Go to the Structure tab, select the Wall tool, choose our masonry wall type, and check that the following properties are correctly set. First, make sure the wall is being created with a height constraint, and in this case, we'll choose unconnected height. Next, we'll model the wall starting from the end of this beam and going up to the reference line we previously drew. Once the wall is placed, we can go to the 3D view to finish setting the necessary specifications. The first thing we notice is that the height of the existing wall is 1.18 meters. So we go to the new wall and set its height to 1.18 as well. Now we can see that the wall we just placed is still vertical, while the existing wall is sloped. So we need to adjust the new wall to match the same inclined profile. To do that, switch to a view between the left and front point of views, select the wall, and click Edit Profile. Then, select the line that defines the top edge of the wall and drag it down until it matches the lower slope of the adjacent inclined wall. A warning will appear indicating a constraint. Choose Remove Constraints and then delete any leftover line segments at the top. Once the shape is adjusted, click Finish to complete the profile edit, and now the wall should match the sloped configuration of the other side. The last step is to assign the 4D task ID to this wall. Referring to the other wall, we can see its value is 106, so we assign the same value of 106 to this newly created inclined wall. Now we can move on to modeling the inclined beam. To do this, we return to the roof start view. Before placing the beam, let's first verify which beam type we need to use. As we can see, it's the one named cubierta, with dimensions of 0.15 by 0.22. So we go to the Structure tab, select the Beam tool, and from the list, we look for the beam named cubierta, with dimensions of 0.15 by 0.22. Once selected, we proceed to model the beam along the same line where we previously modeled the inclined wall, extending it all the way to the end of the module. You may notice that the beam is slightly offset to the left. To correct this, use the arrow keys on your keyboard to adjust it so it aligns properly. Once the beam is aligned, switch to the 3D view. With the beam selected, we now need to adjust the vertical offset so that its end sits directly on top of the inclined wall. Depending on the direction you modeled the beam, you'll need to modify either the start or end offset. If you place the beam starting from here and going here, you'll adjust the start level offset. If you modeled it the other way around, you'll need to adjust the end level offset. In this case, I modeled it from here to here, so I'll adjust the start level offset and set it to 1.4 meters. Now, as you can see, the inclined beam is positioned correctly on top of the inclined wall. The final step is to assign the correct 4D task ID, which in this case is 93. The elements left to model for the roof are the roof surface itself, like this one here, and the joists that will support it. Although in actual construction, the joists would be placed first and then the roof installed on top. In this case, we're going to start by modeling the roof surface. That's because it will help us define a modeling plane we can later use to place the joists accurately. To model the roof, we begin by going to the roof end view. Here, we'll adjust the view range so we can see the CAD plan we worked with in the previous video. Open the view range settings, and in both bottom and depth, set the offset to -2. Click OK, and now we can see the plan that shows the outline of this module's roof. Now go to the Structure tab. In this case, we're going to use the Floor tool to model our roof. Why are we doing this? Because in this project, we have a floor family that was specifically created to represent the roof material. So we'll use that. Select the Line tool and use it to sketch the roof outline. Follow the shape indicated in the plan. Once that's done, we've completed the initial modeling of the roof element. If we now switch to the 3D view, we'll see that the roof is there, but it's still flat. We haven't yet applied the slope that makes it an inclined roof, so we go back to the roof end view. Select the roof and choose the Edit Boundary option. Then choose the Slope Arrow tool. This will allow us to define the pitch of the roof. We'll draw the slope arrow from the outer edge of the roof toward the inner edge. After drawing the arrow, a set of properties will appear. We're going to make the following changes. Set the start level to roof start and apply a start offset of 0.03 meters. For the end level, select roof end and set the end offset also to 0.03 meters. Apply these changes. Now exit sketch mode and return to the 3D view. You'll see that the roof is now correctly sloped, resting on top of both the inclined beam and the inclined wall. To finish this step, we need to assign the appropriate 4D task ID to this roof element. Referring to the roof of the adjacent module, we can see that its 4D task ID is 1001. So we select our roof and assign it the same value. With the inclined roof now fully modeled, we can move on to the next task, which is modeling the joists that will support it. To do this, we need to define, as I mentioned earlier, a work plane with the correct inclination so we can model the joists accurately. We start by going to the Architecture tab and looking for the option called Show Work Plane. This lets us see the current work plane used in the project, which is completely horizontal by default. Now we need to either modify this work plane or define a new one. To do that, we click on Set Work Plane. Then we choose the option to set the work plane based on an existing surface, and that surface will be our roof. That's why we modeled the roof before the joists, because we needed it to define this inclined plane. As you can see, the new work plane now follows the slope of the roof, and this will be the plane we'll use to model our joists. Next, go to the Structure tab and select the Beam System tool. Now we'll define the properties for the joist we want to model. First, we change the beam type, selecting the one named Hollow Structural Section. Then we define the layout pattern. In our case, we'll model a fixed number of joists within a specific area we're about to outline. We're going to model 8 joists. To define the area where the joist should go, we do the following. Make sure the Boundary Line tool is selected. Using this tool, we click along the edges that define the boundary where the joists will be placed. Once the boundary is selected, we then choose the tool that lets us define the joist direction. Select that tool, then click on the Line tool. With it, we draw a directional line from one end of the space to the other, indicating the path the joists will follow. Once everything is defined, click Finish, and Revit will automatically generate the joists. Now, as we can see, our beam system has been modeled. If we select the roof, we can view it more clearly and confirm that the joists were created correctly underneath. The only remaining step is to assign the 4D task ID to these joist elements. To do that, we'll temporarily hide the roof so we can easily select the joists. To find out which value to assign, we'll also hide the roof of the adjacent module and check its joists. We see that the 4D task ID is 102. So we assign this same value, 102, to the new joists we just modeled. And with that, we've completed the modeling of the final structural elements for the roof, wrapping up this stage of the project.